Above what seems to be the familiar night sky, there is a structure so huge that its boundaries do not fit into the human imagination. In this darkness, permeated by the light of ancient stars, a giant starry ocean, the Milky Way, slowly rotates. Its spirals stretch over hundreds of thousands of light years, and within them, worlds are born, live, and disappear, each of which carries its own history of light and time. The depths of this galaxy are not static. They are constantly moving, as if obeying the invisible currents of gravity.
Dense clouds of gas are compressed to the limit, and a new source of energy flashes at their center, a star that can shine for billions of years. Nearby, the already extinguished luminaries leave behind dark traces, but even in this darkness, there remains the structure, order, hidden architecture of the cosmos. At the center of the galaxy is a region where the density of matter reaches incredible values. There, the movement of stars accelerates. Their orbits bend under the influence of a powerful gravitational source. The energy of this region affects the entire structure, holding the spiral arms in their shape, like a gigantic mechanism that works non-stop through the ages.
The spiral arms stretch outwards like giant streams of stellar matter. They concentrate regions of active star formation, where gas and dust turn into bright stars. These regions look like dense knots of energy slowly moving across the galactic disk. Their movement is not chaotic. It is subject to the complex laws of gravity and rotation. Between these arms lie less dense spaces, where the light is more evenly distributed. The stars there are older, their radiation is weaker, but they form the stable basis of the entire system. Their movement is smooth and measured, as if they are part of a huge cycle repeated over billions of years.
Inside the galaxy, there are regions where gas clouds reach colossal sizes. They consist of hydrogen and dust molecules, which are gradually compacted under the influence of their own mass. Within such clouds, conditions arise under which the process of birth of new star systems begins. This process can last for millions of years, gradually converting cold darkness into light sources. Each new star becomes the center of its own dynamics. Disks of matter are formed around it, from which planetary systems can arise. These processes occur constantly, and the galaxy remains a living structure where there is no final point. There is only continuous change.
But not everything inside this system is calm. Sometimes stars get too close to each other, and their gravitational fields begin to interact, changing their trajectories. Such events form new flows of matter, redistribute energy within the arms, and create complex structures that persist over time. Far from dense regions, there are rare star clusters that slowly rotate around the center. They are the remnants of ancient formation processes preserved from the early stages of the galaxy's development. Their movement is almost imperceptible, but they help keep the total mass of the system in balance.
The galaxy continues its rotation, and with each revolution, there are changes that cannot be seen on short timescales. However, on the scale of billions of years, the structure changes completely, redistributing stars, gas, and darkness into new forms. And somewhere in the depths of this system, an endless cycle of the birth and disappearance of stars continues, where each point of light is part of a much larger process that has been going on since the formation of the galaxy itself.
Inside this huge rotating structure, the movement never stops. Streams of matter, stretched for thousands of light years, slowly shift along the spiral arms, as if following an ancient rhythm set by gravity itself. Gas clouds collide, contract, and disperse again, leaving behind traces of future stars that will not appear in visible light for a long time, but already exist as potential sources of energy.
In some areas, the density of matter becomes so high that the space inside the clouds begins to lose uniformity. These zones turn into the cradles of stars, where each particle of matter gradually submits to a general contraction. The temperature inside such regions rises until the moment when the thermonuclear transformation begins is reached. Then, a new source of light appears, and the darkness around it begins to slowly recede. But not all stars are born equally. Some form alone, others appear in groups, creating clusters where gravity binds them together. Such stellar ensembles can exist for billions of years, gradually dissipating but maintaining the overall dynamics of motion. Their light merges, forming intricate patterns of brightness inside the sleeves.
Far from the central area, the structure becomes more sparse. Here, the stars are more freely distributed, and the distances between them increase to incredible proportions. Despite this, even in these voids, movement is preserved. Each star continues its rotation around the center, obeying the total mass of the galaxy, which remains an invisible but dominant factor in all dynamics.
Inside such distant regions, you can observe ancient stars that formed in the early epochs of the system's existence. Their chemical composition differs from younger stars because they arose in conditions when space contained fewer heavy elements. These stars are peculiar witnesses of the early stages of the formation of the entire structure. In the center of the galaxy, the conditions are completely different. There, the movement becomes rapid, and the density of matter increases to the limits at which space begins to behave unusually.
The orbits of stars become complex, elongated, sometimes intersecting in complex trajectories, which are formed under the influence of a powerful gravitational source. This center influences the entire galactic system, maintaining its integrity. Between these extremes, the central region and the periphery, is the main disk, where most of the stars and gas clouds are concentrated. It is here that the most active processes of transformation of matter take place. Clouds collide and contract to form dense structures that eventually evolve into star systems. Sometimes, especially dense clusters occur in such regions, where stars form almost simultaneously. These areas may look like bright knots of light slowly moving along the sleeves. Their energy gradually dissipates, but traces remain in the structure of the galaxy for a long time. The fabric inside the sleeves is not evenly distributed. It forms waves of density that travel through the disk like giant vibrations passing through the entire system. In these waves, stars are born, and it is they who determine the shape of spiral structures. Without these waves, the galaxy would have lost its distinctive appearance. The outer regions of the system continue to rotate in near total darkness. New stars rarely appear there, and space seems calmer. But even there, the gravitational influence of the center remains, which keeps each star on its path. These peripheral zones are an important part of the total mass and dynamics. Sometimes in these distant regions, one can find the remains of ancient star clusters that have been gradually pulled out of denser regions. They move slowly,
almost imperceptibly, but continue to participate in the overall dynamics of rotation.
Within this whole system, time is felt differently. Processes that seem instantaneous on the scale of cosmic history actually take millions or billions of years. Stars are born, live, and disappear, but the structure itself continues to exist, changing so slowly that its shape remains recognizable. And somewhere in the depths of the spiral arms, the endless formation of new light sources continues. The matter collects, condenses, and turns back into a glow, adding new dots to the galaxy's already existing pattern.
Cold, dark streaks of dust stretch through the thickness of interstellar space, hiding entire regions of the galaxy. These giant clouds emit almost no light, but it is inside them that one of the most powerful processes in the universe begins. Gravity gradually gathers matter into dense cores. The pressure increases, and after huge intervals of time, a new flame of the star appears inside the darkness. At first faint and hidden by a dense shell of gas, then more and more bright, it begins to push out the surrounding matter with streams of energy. Some areas inside the spiral arms look like giant glowing nebulae. Their glow is due to the powerful radiation of young stars that permeates the surrounding gas. These regions are filled with complex structures, long filaments of dust, dense knots of matter, and expanding bubbles of hot matter. All this is constantly moving, colliding, and changing shape. In the depths of the galactic disk, processes are taking place that cannot be seen directly. A huge amount of matter is hidden by dense clouds of dust that block visible light. But infrared and radio wave radiation passes through them, revealing the hidden architecture of the inner regions. There are entire chains of gas structures stretching for hundreds of light years.
Some of these structures are unstable. When the mass inside them becomes too large, rapid compression begins. Especially massive stars appear, whose energy is so great that they literally burn the space around them with powerful streams of radiation. Their life is short by cosmic standards, but extremely bright. When such stars reach the final stage of their existence, there is a tremendous release of energy. The outer layers are ejected into the surrounding space at tremendous speed, creating expanding shock waves. These waves sweep through the interstellar medium, colliding with clouds of gas and changing the structure of entire regions of the galaxy. After such explosions, dense objects remain, such as neutron stars or black holes.
Inside the Milky Way are millions of similar remnants of ancient stars. Some of them are almost invisible. Others emit powerful X-rays. Their gravity is so strong that they are able to capture matter from the surrounding space, creating red-hot disks of matter. The central region of the galaxy remains especially mysterious. There is a supermassive object hiding there, whose mass exceeds the mass of millions of stars. Entire stellar streams revolve around it, moving at incredible speed. This area is filled with hot gas, magnetic fields, and powerful radiation streams.
Sometimes energy bursts occur near the center. Huge clouds of matter are accelerated and ejected far beyond the galactic disk. Traces of such processes are found even in distant areas, where space preserves the imprints of ancient core activity. But the galaxy itself does not exist in isolation. Around it are dwarf satellite systems, moving slowly under the influence of its gravity. Some of them gradually collapse, stretching into long streams of stars.
These streams become part of the outer halo surrounding the disk.
The halo of the galaxy is almost invisible. It has few bright stars, but it contains a huge mass. Much of this mass remains mysterious because it does not emit light. It is this invisible component that keeps the outer regions of the galaxy from collapsing and affects the rotation speed of the entire structure. Without this hidden mass, the spiral arms would have lost their stability long ago. But the galaxy continues to exist as a single system, despite the colossal distances between its parts. This indicates the presence of an invisible structure permeating the entire disk and the surrounding space.
On the outskirts of the galaxy, space becomes especially quiet. There are few bright stars there, and the interstellar gas is extremely sparsely distributed. But even these areas continue to participate in the overall rotation. Slowly and almost imperceptibly, the outer regions move around the center, completing one revolution in hundreds of millions of years. Sometimes dense clouds of gas coming from intergalactic space pass through the disk. They can collide with existing structures, causing new waves of star formation. In this way, the galaxy continues to receive matter, supporting the formation of new stars.
Spiral arms never remain unchanged. They slowly shift, change shape, get stronger or weaker. Some areas become brighter due to the appearance of young stars, while others gradually dim as star formation activity decreases. Even now, there are regions within the galaxy where particularly massive clusters are forming. Their light is so powerful that it is visible through vast distances inside the disk. These areas become centers of new processes that affect the surrounding space. Magnetic fields are constantly propagating inside the interstellar medium. They permeate gas clouds, direct the movement of charged particles, and affect the structure of nebulae. These fields are invisible, but their impact is felt on a huge scale.
Cosmic rays, accelerated by supernova explosions and core activity, sweep through the galaxy at almost the speed of light. They collide with gas particles, creating complex flows of energy that fill interstellar space with invisible motion. And while the spiral arms continue to rotate slowly, the cycle of transformation of matter inside the galaxy does not stop. Some stars disappear, leaving behind heavy elements and shock waves. Others are just beginning their formation in cold clouds of gas. All this turns the galaxy into an ever-changing system where darkness and light are connected by a single movement of the cosmos.
Inside the huge rotating disk of the Milky Way, the slow redistribution of matter continues, where every particle of gas and dust obeys a common gravitational symphony. There are no fixed boundaries, and even the densest structures gradually change shape under the influence of endless motion. Space seems stationary only at first glance, but in reality, it is in constant dynamics, where millions of processes occur simultaneously. Density waves passing through the spiral arms create regions where matter contracts and heats up.
These waves act as a giant mechanism that directs gas clouds into zones of future star formation. When such regions reach critical densities, new star systems begin to form and darkness gradually gives way to light. Some of these regions become so active that they form entire star complexes. Inside them, young stars are arranged in groups surrounded by the remnants of the gas from which they were born. This gas is gradually dissipated, but some of it can be reincorporated into the new object formation cycle. Deeper inside the galactic disk are cold regions where temperatures are so low that gas molecules exist in stable forms. These regions seem almost empty, but they serve as reservoirs of future matter. Over time, even these cold zones can become active if they are affected by shock waves from supernova explosions or the passage of dense spiral structures. In the central region of the galaxy, the movement becomes more chaotic and rapid. Here, stars orbit a supermassive object whose gravity forms a complex dynamical system. The orbits intersect, stretch, and curve, creating a dense stellar stream that cannot be observed as a static structure.
This central region is also a source of powerful radiation. The hot gas falling inside the gravity well heats up to extreme temperatures and begins to radiate in different energy ranges. These processes affect the entire galaxy, creating streams of energy that extend far beyond the core. The outer regions of the galaxy, on the other hand, remain calmer. There, stars move in more stable orbits, and the density of matter is much lower. But even here, changes are taking place, albeit on much longer timescales. Sometimes flows of matter, stretched by the gravity of neighboring systems, pass through the periphery. These structures can connect different galaxies, creating thin bridges of gas and stars. They gradually change the distribution of mass and affect the future evolution of the system. Within the entire galaxy, the processing of elements continues. Light elements that arose after the formation of the first stars gradually turn into heavier ones through thermonuclear reactions inside the stellar interior. When stars complete their life cycle, they eject these elements back into space, where they become part of new generations of stars and planetary systems. Thus, the galaxy functions as a continuous cycle of matter transformation. No part of it remains unchanged, and even the most stable structures are subject to change over time. This movement has been going on for billions of years, creating a complex and ever-evolving system in which every point of the world is part of a huge process. Within the structure of the Milky Way, a slow but continuous redistribution of energy continues, where matter and radiation are in constant exchange. Gas flows stretched along spiral arms move unevenly, forming complex density patterns that change under the action of gravitational waves. These waves pass through the disk like invisible pulses that set the rhythm of all galactic dynamics.
Within these flows, areas of increased concentration of matter are formed, where the movement of the gas slows down and compression increases. This is where a new phase of transformation begins, in which cold matter gradually becomes a source of radiation. Emerging stars alter the surrounding space, heating the gas and creating zones of ionization that expand for tens of light years. Over time, such regions can combine to form extended star-forming complexes. Their structure is heterogeneous. Dense nuclei are interspersed with sparse zones where the formation process has not yet begun. These regions remain unstable, and their shape is constantly changing under the influence of internal currents and external shock waves.
Deeper in the galactic disk, there are zones where the interstellar medium becomes so sparse that star formation almost stops. However, even there, weak dynamics of gas and dust movement remains. These regions serve as transition zones through which matter passes to more active regions. In the central part of the galaxy, the density of matter increases many times over. Stars here move along complex trajectories, obeying a powerful gravitational field.
Their orbits form a dense dynamical core where each change in mass affects the entire structure. This interaction creates a constant restructuring of movement in which there is no stable equilibrium. Near the very center is a region of extreme energy where the gas is heated to millions of degrees. Here, matter exists in a state that cannot be observed in the quieter regions of the galaxy. Radiation streams leave this zone and spread outward, affecting the state of the surrounding disk and regulating the processes of star formation. In some cases, the activity of the central region increases, and then powerful emissions of matter occur. These emissions propagate along the axis of rotation of the galaxy, going far beyond the disk. They form huge structures that gradually dissipate into intergalactic space, leaving behind traces of energy and ionized gas.
The outer regions of the system contain many ancient stars whose orbits span vast distances. These objects move slowly, but their contribution to the total mass of the galaxy is significant. Their distribution forms a faint but extended halo that surrounds the entire disk and creates additional gravitational stability. Between these stellar layers, there are streams of dark matter that do not emit light but affect the motion of all visible objects. Their distribution covers not only the disk, but also the entire galactic structure, forming an invisible framework within which all the movement of matter takes place.
Sometimes gas streams captured from outer space pass through the periphery. These currents are gradually drawn inward, replenishing the reserves of matter in the galactic disk. They become part of the cyclical exchange of matter between the inner and outer regions of the system. Over time, stars born in different parts of the galaxy begin their movement around the center, gradually changing their position relative to the spiral arms. Their trajectories cross different zones of density, which affects the distribution of matter and the formation of new structures.
Inside the spiral arms, the process of energy accumulation continues. Clouds of gas compress, collide, and form complex nodes, inside which the formation of new stars begins. These nodes become temporary centers of activity, gradually dissipating after the completion of star formation. Each cycle of star formation changes the local structure of the galaxy, creating new regions of density and sparseness. These changes accumulate over time, gradually transforming the overall look of the system.
And despite all these processes, the galaxy retains its integrity as a single dynamic structure. Its movement continues, supported by the interaction of gravity, radiation, and hidden forms of matter. And within this movement, the process of birth, development, and disappearance of luminaries is endlessly repeated. Within this continuous Milky Way dynamic, each new structure becomes part of a larger cycle in which matter is constantly redistributed between states. Clouds of gas that have lost stability break up again into smaller fragments, and then, under the influence of gravity, they reassemble into dense cores. This process repeats endlessly, creating a complex network of transitions between darkness and light.
In some regions of the galactic disk, especially extended fibers of interstellar gas appear. They stretch for hundreds of light years and form structures that resemble giant filaments connecting different regions of star formation. Within these filaments, the movement of matter is uneven. Some areas contract faster, others remain more rarefied, but the entire structure gradually evolves under the influence of gravity and shock waves.
When the density in individual sections of such filaments reaches a critical level, fragmentation begins. Chains of protostellar objects are formed, which then develop into full-fledged stars. These chains can maintain their shape for a long time, creating a sense of order within a chaotic process.
Within the spiral arms, there are also areas where gas and dust form complex vortex structures. These vortices arise under the influence of the interaction of gravitational waves and the rotational motion of the galaxy. They play an important role in the redistribution of matter, directing it to zones of active star formation. As new stars form and begin to radiate energy, the environment is strongly affected. Radiation and stellar winds push some of the gas outward, creating expanding cavities within the interstellar medium. These cavities can connect to each other, forming giant voids surrounded by shells of dense matter.
Such structures gradually change the internal architecture of the galaxy. They do not destroy it, but redistribute the density of matter, creating new conditions for future generations of stars. As a result, the galaxy remains in a state of constant transformation, where each epoch is different from the last. In the central region, traffic remains particularly intense. The stars here not only revolve around a common center, but also interact with each other through gravitational perturbations. These interactions can alter their orbits, moving them to more elongated trajectories or moving them closer to the core.
Near the very center, the density of matter reaches such values that even light and radiation behave differently. Streams of energy swirl around the supermassive object, forming bright accretion structures. These structures become a source of powerful radiation that affects the entire galactic system, regulating the rate of star formation in distant regions. Sometimes the central activity is so intensified that jets of plasma are ejected from the nucleus, spreading over vast distances. These jets pierce the environment, creating long channels of energy that can be traced even to the most distant regions of the galaxy.
On the outskirts of the system, the slow movement of old stars continues, whose orbits extend far beyond the dense disk. These objects form a sparse halo that surrounds the entire galaxy and serves as a connecting element between its inner and outer parts. This halo also contains the remains of destroyed dwarf systems. They were gradually absorbed by the larger galaxy, and now their stars are distributed in faint streams stretched across space. These threads retain the memory of past interactions and mergers. A galaxy does not exist in isolation. It interacts with the surrounding intergalactic space, exchanging matter and energy. Sometimes external clouds of gas penetrate inside, becoming part of its structure, and sometimes vice versa. Internal flows leave the system, spreading into the environment.
Over time, these processes lead to slow changes in the overall shape. The spiral arms may become more pronounced, or, on the contrary, weaken, and the distribution of stars gradually shifts depending on internal dynamical processes. And despite the complexity of these interactions, the system remains stable. Gravity binds all its components into a single whole, allowing for a huge structure in which each part influences the other, and each process becomes part of an endless cosmic cycle.